The following systems consist of two functions. While one or both of the equations may be nonlinear, the system can still be solved by finding points of intersection on a graphing calculator. So, think back to like a really long time ago, like October or late September. Late September, okay? When we had a system of equations, what did we do to solve it? Well, one of the ways that we solved it was we graphed it, right? What were we looking for when we graphed it? The intersection. Excellent. And at that point, we were graphing just lines, right? We used the calculator. Sometimes we did it by hand. I made you do it by hand first, right? Like I always do. Then I said, okay, let's do it a little bit faster way in the calculator, okay? We solved it with substitution and combinations as well. Do you remember that? Okay. But that was when we had just linear functions. Now we have nonlinear functions. How are we going to do it? How are we going to solve them? We can do it the same way, okay? So solving by graphing is what we're going to start with. If we're solving, in this first case, we have two parabolas, right? How many possible solutions can we have? Well, we could have two, right? If we had a parabola here and a parabola here. Oops, that's not very good. Let's pretend there's one there and one there, right? What else could we have? One intersection, so we could have, what about this, and then like this? Wouldn't that be one solution right there? Would they cross anywhere else? No? Okay. What about, what are the other possibilities? No solution? What would that look like? Or they didn't cross at all, right? So maybe I have a really wide one, and then I have a narrow one inside of it. Or they could even have the same like multiplier in quadratics. We don't call it a slope, but that kind of what we're talking about, where it doesn't matter how far this one goes out because this one's also going out the same speed, right? So we have no solutions. We could have one that's opening up and one that's opening down, and they would never touch like that. Okay. Can you think of anything else? Yeah, what if one was right on top of the other one? How many solutions would there be then? An infinite number of solutions, right? Here's one, and then here is the other one, right? There's an infinite number of solutions there, okay? So we're not going to just have two parabolas. We might have a parabola and a line. We might have a line and a square root function or something like that. Okay, it's really just going to depend on what's going on. Let's look at this first example right here. If we start a new document in our calculator that is a graph, I'm going to zoom in just a little bit so it's easier to see. Let's put in both of these two equations into our calculator. So we have x squared plus 4x plus 5. There's one parabola. And then I'm going to tab to open the line again and get x squared minus 2x minus 6. So how many solutions does it look like there are? Probably one. Okay? Everybody point to that solution on your calculator right now. Point to it. See, it's right there? Okay? So carefully, I'm not going to worry about exactness at this point, but I want you to be careful. Carefully, I'm going to switch sides. See what I mean? Carefully. Is that exact? Did I find exact points here? I mean, could I? Yes. I could go to my table, plot all those points, right? That's not the point we're trying to make here. Okay? So there's one. And then I have this other one that goes like way down here, like that. And the point that I care about is that point right there where they cross. Okay? How am I going to go about finding that point using my calculator? Menu, Analyze, Intersection. Okay? What do I have to do with that line? What is it asking for? Right there. Lower bound. That means I have to put it on the left-hand side of the intersection. Anywhere on the left-hand side will do. Then I click my middle button, this button right here. Okay? Notice that it now says upper bound. So I need to move this to the right-hand side of my upper bound. And as soon as I do, a word pops up that says intersection, and so do the coordinates of a point. What are those coordinates? Negative 1.83 and 1.03. That is my solution. I can see that that's the only place they cross, and I know because of my properties of parabolas that that's the only place that they cross. Okay? Any questions? Well, look at number 2. Okay? I'm going to hit tab and up arrow and go ahead and clear that equation. So it's gone, and I'm going to hit tab and up arrow and control clear that equation so it's gone. I'm going to enter my 2 new equations. What shape is this top one? What shape is the bottom one? So the top one's a parabola, the bottom is a line, right? There's nothing squared, and there's just an x in there, isn't there? Okay, so we're going to hit tab, negative x squared plus 2x plus 4. Okay, I expected a parabola. It's a good thing there's a parabola there. Tab, negative 2.8x plus 9.76. Enter. How many points of intersection do you think there are? It's kind of hard to see, isn't it? So remember, we can do this. We can scoot around on our middle button, and I can see the hand, right? The hand's like this. I want to close the hand, so I want to go control middle button, and I want to move that up out of the way. And then I want to move this one, control middle. I want to move that one out of the way, just so I can kind of see what's going on. It's really hard to tell, but it kind of looks like there's only one, doesn't there? Okay, so we're going to do menu, analyze, intersection. Put it on the left-hand side. Put it on the right-hand side. As soon as you move it, you'll be able to see that point show up, and you'll know where the point of intersection is. 2.4, 3.04 is the solution. Okay. What did I forget to do? Graph them. Okay, so I'm going to do that carefully. There's one. Some of you will need to draw these with 2 different colors. Some of you are fine without the 2 different colors. It's up to you. That's the point of intersection. That's the point that we care about right there. Okay? Do you get the idea of what to do on these? Yes or no? Okay? Turn the page and look at problem number 11. While these systems can be solved using technology, they can also each be solved algebraically. So let's follow these steps to solve number 9 algebraically. Compare your solutions with the calculators. Well, we haven't done number 9. So I'm going to do number 9 real quick. I'm not going to write anything down because I'm leaving that for you to do in a little while. But I'm going to get an answer so we have an idea of what we're doing is correct or not. Okay? I'm going to use my control divide to, well, not after I press tab. I'm going to press control divide to give myself a fraction there. So I have 4 over x minus 3. That's a rational function. Hopefully I expected that. I'm going to say 2x minus 6. So, how many solutions do I have? 2. It's hard to see that line. I don't know why it won't show red up on the overhead. If I do some weird nonsense, you can kind of see it. Okay. How many times do I have to do analyze, intersection? Can I do them both at the same time? Analyze, intersection. If I put this over here, and then scoot this over here, do they both show up? No, they don't. Okay? The top one shows up, but the bottom one doesn't show up. So I need to do it one at a time so I can get both of them. Does everybody understand that? Okay, so one of my solutions is 1.59, negative 2.83. Menu, analyze intersection, left side, right side. My other solution is 4.41, 2.83. Okay? I'll let you sketch that later on. All right? But if we're solving this with by these rules, first of all, it says set the two functions equal to each other. Why in the world would we do that? Why would I set these two functions equal to each other? Don't they already both equal y? So if they both equal y, shouldn't they equal each other? Yes or no? Yeah. Okay. So I will say 4 over x minus 3 equals 2x minus 6. How would I go about solving that? I know there's words over here that tells you, but if you'll think about it, how do I go about solving this? Isn't that like over 1? Can't I cross multiply right here to solve for x? Yeah, right? So this is 4 on this side, and this is x minus 3 times 2x minus 6. So x minus 3 times 2x minus 6. Okay? Do we know how to multiply that? Hopefully the answer is yes. How do I go about it? I distribute, don't I? Distribute. Okay, so this is going to be 4 equals 2x squared, zhunk, zhunk, minus 6x, zhunk, another minus 6x, zhunk, and then plus 18, right? That's a 1. Pretend it's a 1. So now let's combine our like terms. Okay? I've got those two terms I can combine. I have 4 equals 2x squared minus 12x plus 18. What kind of problem has this become now? This is a quadratic, isn't it? If it's a quadratic, what do I need it to equal? 0. So subtract 4 from both sides. 0 equals 2x squared minus 12x plus 14. Absolutely. So I have a couple choices here. It says use the quadratic formula. And some of you really like to use the quadratic formula. You just go right ahead. Right? Is this something we could factor? Now think carefully. It's something we could try to factor, isn't it? But we know what the answers are going to be ahead of time because we actually already did this graphically, right? Is this something that I can solve using factoring? No. Okay? But keep that in mind. Even though it says use a quadratic formula, we have factoring at our disposal. Okay? So let's go ahead and do what it tells us to. Follow directions. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Does anybody remember that song? Okay, good. Good. So now I just need to simplify it. X equals 12 plus or minus the square root of, I did say negative b, but b is already negative 12. Good catch. Okay. So 12 squared is 144, which means negative 12 squared is 144. Minus 4 times 2 times 14. 4 times 2 times 14. 112 all over 4. 12 plus or minus the square root of, what's 144 minus 112? 32 over 4. Does anybody know the square root of 32? I don't. Right? I don't. But what is our, normally we would stop right here, right? But what's our goal? To find a point on a graph. So I have to put this into my calculator and get some answers out, don't I? On my current page, remember this is we've been graphing stuff, I can control doc, I can add a page. This time I just want to add a page as a calculator. And I want to say 12, whoops, not yet. I want to do myself a fraction. 12 plus the square root of 32 over 4. And I want to do 12, whoops, not yet. Slow down. 12 minus the square root of 32 over 4. Did I expect those two numbers? I mean, was I hoping for those two numbers? Oh my goodness. Yes. But what does this tell me? That just tells me the x values, doesn't it? How do I go back and find the y values? I substitute them in, don't I? Okay? Substitute them back in to find the y values. Substitute them back where? In either one of these. Which one would you choose? The second one? Why would you choose the second one? Because it's easier. Okay? Do you have any questions about that? Circle these problems, please. Number 4. Whoa, zoom out. Number 4, number 6, number 7, and number 9. We have to do 9 for that to make sense, right? And I already did most of it for you, so stop complaining. 12, 13, 16, 18, 20. Okay? Any that I did not have you circle that you do are extra credit when I check tomorrow. Do you have any questions?